Okay, so let's talk about roots with other indices. So 8.2. We already know that the nth root of a to the mth power is a raised to mth power over nth in the denominator. So now when we're asked to find the cube root of 8, we are really asked to find what number we cube to get 8. So what number we cube to get 8? So the answer is 2. 2 to the third is 8. So therefore, the cube root of 8 is 2. Now what if I have the fourth root of 16? Same thing. I'm asked, what do I take to the fourth power to get 16? And the answer is also 2, because 2 to the fourth equals 16. And so on and so forth. So in this case, the cube root of 8 is 2. This is also possible because the index is an odd number. Which number we raise to the third power to get the negative 8?
Negative 2.
Negative 2, indeed. Remember, odd indices are friendly. Even indices require a lot of attention. Now, we're asked to find which number we raise to the fourth power to get 81. And then there is a minus in front, which is fine. So negative the fourth root of 81. We know that if we raise 3 to the fourth power, we get 81. So then this number is 3, with minus in front is negative 3. Now with the graphing calculator, this is how one option. The option that I like to use is simply 81 power, the caret power, in parentheses, 1/3. I'm sorry, 1/4. This is what I like. And I get 3. Here's another option. If you click on math, you will see that it's number 5 that has an x as the index. But you have to put the index first and then use 5 in math. So I have 4. I go to math. I choose 5. It already puts it up as an index. And then 81. And I press enter. And I get 3. Of course, then I have to multiply by negative 1 in front. Again,
if you put the negative in front of it.
Oh, yeah, very easy. So you go in front of it. You click on insert, second and insert, and you put the negative sign, and you get negative.
Oh, okay. So you can use the calculator that way too.
Yeah. But I prefer the power. So once you understand that any radical is a power, you will always remember that the square root is power 1/2, the cube root is power 1/3, the fourth root is power 1/4, and you will never need to go click, 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 click into math.
So it's always 1 over whatever the power is?
Yes,
So it's a bit
whatever the index is. But if you have a different power, it's a different story, right? So if I'm asked, for example, to find the square root of 9 to the third, then I have 9 to 3 over 2. But if I only have the square root of 9, then it's 9 to 1/2. If I only have the square root, the cube root of 27, then I have 27 to 1/3. But if it has a power, then I use the full translation, so to speak. Okay. Any questions? So here we have -3. Negative is coming from the outside and 3 from the inside. Okay, the 8th root of 0. See, the 8 is way up there as the index. It's not in front of the root symbol. It's way up there. So the answer is,
0.
Of course.
Because that's 0 to the 1/8, or no?
0 to the 8th
Yeah,
power? Yes.
Yeah.
So what do we get now? Now we know and we understand that the radical is a power, and what do we get?
Because it's the power of 1, basically.
So it's, yes, 7/7. And there is no problem, yes. So that's 3. Good. Careful, careful, careful. Careful with this one. They're trying to. Now, if I know nothing about even powers, I will say this, and that would be a terrible mistake. Because no even power can be a negative number. Never. Never, ever, ever. If it has minus in front, yes, it can. So this is terrible if I do this. Here's what I need to do. Only because it's an even index. Otherwise, I will blindly, if it were odd, 17 and 17, I would write -6 and not even think about it at all. But here I cannot, because an even index cannot have a negative answer. One more time. Even, positive or 0, and answer positive or 0. Carved in stone. Always and forever. But odd, -0, positive. Answer, -0, positive. No discussion. No problem. None whatsoever. But if I have an even, and nothing else in front, of course. If I have an even index, the answer must be positive or 0, and underneath I have to have positive or 0. But if the index is odd, I don't even think about it. If this number is negative, the answer will be negative. If this number is 0, the answer will be 0. If this number is positive, the answer will be positive. I don't care. But with the even, not only the inside has to be greater than or equal to 0, but the answer, the output, has to be positive or 0. So then, with this problem, be very careful. I have to rewrite it as -1 to the 18th, which is +1, times 6 to the 18th, which is 6 to the 18th. And now I can write 6. Very careful, because the index is even. The answer can never be negative, unless there is a minus in front. But otherwise, it will never be negative. It's mandatory to be positive or 0. Simplify the given expression. The index is 3, so I don't care. There is never a need of absolute value on an odd index, ever, ever, ever. So then the answer is just y. It doesn't need anything, because the index is odd.
And it's positive.
What about here? The index is odd. Would you write x minus 9 or the absolute value of x minus 9?
Absolute value.
Never ever on an odd index. The odd index has no restrictions. It doesn't have restrictions inside. It doesn't have restriction outside. Good. What about this one? Careful. Of course, the outside will have a minus, but I'm talking about the the fourth root, what would you write the answer for the fourth root?
It would just be 2p plus 9
With the absolute value.
with absolute value. Yeah.
With the absolute value.
Awesome.
Yes.
That's even.
2p plus 9.
And
Because,
you carry that negative in front of the absolute value.
say it again.
And you do carry that negative in front of it, the absolute value.
That negative is the fourth root multiplied outside. I don't care. Whatever is outside, I cannot put it in anyway, because by the order of operations, I have to perform the power first. I cannot distribute. I have to perform the power first and then multiply. And that's it. And I need the absolute value because the index is even. Okay, so let's take a look. Match the rational exponent expression in column 1 with the equivalent radical expression in column 2. Okay, perfect.
So the first one is the third one.
So here we have negative
Wait, no,
negative 5x to 1/3.
it's the first.
So it's negative 5x and power 1/3. Does everyone understand this? So it's the cube root. Yes? So it's power 1/3, which means the cube root. So it's the cube root of negative 5x. Agreed?
Yes.
Now the next one is the same thing, but it has to go to the denominator. Entirely, not piece by piece. This. I'm sorry, that was positive, sorry. This one.
This is the negative power.
Because it's the negative power. So 1 is at the top, and the cube root of negative 5x in the denominator. Do we agree with B? Okay. This is simply the cube root of 5x. There is nothing else. The next one is 1 over the cube root of 5x. And that's it. One final check. Okay, I think we got the idea. Yes? We want to identify, this is a good exercise. We want to identify which of the following are not real numbers. Remember, the rational power is a radical. The first one is the square root of negative 16. Is this a real number or not?
Not.
Not. The cube root of negative 64.
That could be real.
Exactly. The fourth root of negative 81.
No.
No.
Can you explain why?
Yes.
This is even.
Yes. Let me write it. Both or just one.
Just one. I think I get the idea if we do just one.
So negative 16 raised to 1/2 is the square root of negative 16, which is not real.
There's an imaginary 2 above the power, which is the 1/2.
That makes sense.
Then the other one was negative 81 to 1/4. So this is the fourth root of negative 81, which is not real.
This is an even to a negative, so you can't even.
Yes, the even is trouble. Even power requires underneath positive or 0 and requires the answer to be positive or 0. The odd, we don't care. Good. So let's move on to the fifth root of negative 32.
That is a real number.
Good. Then we move on to the sixth root of negative 1.
It doesn't exist.
Very good. It's not real. And the seventh root of negative 1.
It's 1. Oh, that's negative.
It's negative. Perfect. Part B.
You showed both that were not real. Can you show me one that is real and how you got there?
Yes, negative 1 to 1/7. Negative 1 to 1/7 is the seventh root of negative 1, which is real. Because the index is odd. And when the index is odd, we don't care.
That makes sense. Thank you.
Sure. No restrictions when the index is odd. Describe all the values of b and counting number n for which b to 1 over n is not a real number. B to 1 over n. Okay.
It's not a real number. So anything that's even.
So when we have a negative number and n is even. So when b, which is under the square or under the root, when b is negative and the index is even, all these will not be real numbers. Rewrite the following radical with a rational exponent. You would write 3, the fourth root of 3y. How? In parentheses for 3y to 1/4, or 3 to 1/4, y to 1/4. Both are acceptable. I prefer this because I don't want parentheses, but both are acceptable. So the fourth root of 3y is 3y in parentheses. The whole thing is raised to 1/4. So 3 to 1/4 times y to 1/4. Is this clear? Good. Use integers or fractions for any numbers in the expression. Rewrite the rational exponent. So I will write it as 3 and the power is 1/4. 1 divided by 4. And then I will write y. And then I will put the power. It's not what I meant. I will put the power and then the fraction, and then I will have 1 divided by 4, and it should take both, with parentheses and without parentheses. Rewrite the following radical with a rational exponent. So the 8th root, see, it's way up there and it's much closer to the radical symbol. Okay, so I will rewrite it as, first of all, as the 8th root of x over the 8th root of 5. And then I will write x to 1 over 8 and 5 to 1 over 8. Any questions? Any questions? Okay. Use rational exponents to rewrite the radical expression. So we have here 1 over the 5th root of x to the 3rd. And they want us to write as x to which power?
1 over x to the 3/5.
Yes, yes. And then if you bring it up, it's negative 3/5 indeed. Yes.
Oh, okay.
Yep, absolutely. Good. Rewrite the expression in radical notation. Good. Going backwards. Z to negative 2/7. How do we write Z to negative 2/7?
That would be
Definitely 1/.
1/z. The power square root with
Careful,
7.
the denominator is always the root. The 7th root of Z squared. So the power is always the numerator, the index is always the denominator. So we will write it as a fraction, 1/. Type an exact and use radicals as needed, use positive exponent. Oh, it says use positive exponents. Good. So you click on this, using radicals as needed. Okay, so this is the 7th root. How do I put the index? It won't let me put the index.
Use the arrow keys.
Yeah, I'm trying to do that. I think it took it. Okay, very good. Use rational exponents to rewrite the radical expression. So x to which power?
To 3/4. Negative 3/4.
Yes, I don't know why it appears so up there, but we'll see. Oh, simplify your answer. Use rational exponents to rewrite the radical expression. Do they want us to write 1/? It's not clear. It's not clear to me what they want here. Do they want a negative exponent or they don't? Okay, they did want a negative exponent. Ah, perfect. The 7th root of x plus 2.
X to the 1/7 plus 2 to the 1/7.
We can never separate. It's a
That's
sum.
true.
It's a
It's
sum
a
of
term.
terms. So we can only write x plus 2 to which power?
The 1/7.
1/7. Very good. Awesome. I know. That's what they do. Good. What about the 4th root of x to the 3rd plus y to the 3rd? How do we write this one?
Plus. Would you do the same thing?
Exactly.
To 1/4.
That's it. That's absolutely it. There is nothing else we can do here. Good. Write each expression in radical notation, evaluate la la la. Okay, very good one. 1/32 raised to negative 1/5. First of all, we discussed this rule, if you remember. When we have a fraction to a negative exponent, I have to flip the fraction and the exponent becomes positive.
And then you got the 5th power of the square root of 32.
No, it's just the 5th power, the fifth root of 32.
5th root, sorry.
And we know that this is 2 because 2 raised to the 5th power is 32. I'm not showing you how to cheat, but you can put this in the graphing calculator. Very easy, but you have to be very careful how you enter it. You have to put parentheses, 1 divided by 32. close, caret for the power. In parentheses, please, -1 divided by 5. And when I hit enter, I have to get 2. Mandatory.
Oh, because, yeah, 32 is the fourth power. Got it. Or, yeah, that makes sense.
Okay? Good.
Or fifth power. That's
So this is 2. We'll stop. What? What? Oh, they wanted this step first. Okay, fine.
that fine print.
The fine print, yes, it always gets me. Write the expression in radical notation and then evaluate it. Okay. So 243 raised to -3/5.
That's 1 over.
Exactly, that's the first step. The 5th root of 243 to the 3rd power. This isn't easy to simplify. I'll give you that. So we have ways of doing it step by step. What is the first way? First, I'd like to see what is this 243, if I can replace it by something to a power. So we can do that. So you can take the 5th root, which is of 243, to 1/5. And let's see what we get. And this is 3. So this is basically 3 to the 3rd. So it's 1/3, right? Because the 5th root of 243 is 1/3 to the 3rd power. So this is 1 over 27.
Oh, so you can do the 5th root to.
Yes, very good question. Yes, yes.
And then do it later.
So I can have the 5th root of 243 to the 3rd, or I can have the 5th root of 243 to the 3rd. They mean the same thing. Yes. So
I'm sorry, where did 7 come from?
the 5th root of 243 is 3. 3 to the 3rd is 27. So we determined this first, and we got 3. But then we have to raise it to the 3rd power, and we get 27. So then we have to put in 1 over 27. Rewrite the expression in radical notation. Do not evaluate. Okay. Do they want just? I will put it in 1 over. And this is the 5th root of 243, and the power is 3. And after that, it's 1 over 27.
Tricky. Is that because it's it's not a term, the factor, I guess, because of the power roots?
So once I determine the 5th root of 243 to be 3, then I have to raise it to this power. 3 to the 3rd is 27.
Right, I'm saying the reason why you can do that is because 5 and 3 are multiples or divisions of 243. The multiplication factor, I guess.
No, it's because that's a very good question. Here's why. You mean why I can do this, right?
Yeah.
Okay, very good. Excellent question. Here's why. So we had 243 to power that it was -3/5. Very good. So once I write it like this, here's what happens. 3/5 is either 3 times 1/5 or 1/5 times 3. So I can cube first and then apply the 5th root, or I can apply the 5th root and then cube.
Yeah, that's what I meant, like the multiplication factor.
Exactly. Because that's what I taught you, if you remember. X divided by 2 is the same with 1/2 x. It is the same with x times 1/2.
Right.
And you decide what is more convenient. So this time it was more convenient to apply the 5th root first and then multiply. Then raise to the 3rd power.
Right, because it's a big number, make it smaller.
Exactly. So 3/5 is the same with 3 times 1/5 or 1/5 times 3.
Okay.
Can you apply this directly? Yes, you can. Here it is how. With the graphing calculator. So I can have 243, and then I apply directly 3/5, and I'm done. And I have to get 27. So you can do it straightforwardly. But at the same time, 3/5 can be written as 3 times 1/5 or 1/5 times 3. So first I applied the 5th root, and I got 3, and then I cubed it to get 127. But that's the trick. That's why from the very beginning, like 2 months ago, I said, please understand and be able to read these 3 as the same thing. Exactly. Good point. Okay, let's work on this. Oh, I'm sorry. I exceeded by 3 minutes. I'll give you 3 minutes next time. My apologies. So we only had like 3 questions here, so please complete 8.1 and 8.2, please. 8.1 and 8.2. I'm happy with 70%, so we can discuss anything that you may encounter. My apologies for holding you 3 minutes over.
It's okay.
I promise I'll finish at 2:12 on Tuesday.
Have a great day, everybody.
Have a good weekend.
So please finish up. Please finish up, please.
I had a question from earlier.
Yes.
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 Okay, let me pull it up.
Yes.
It was in 7.2. It's a negative sign that confuses me.
Oh, it was something that we did today?
No, it wasn't
Oh.
today. It's from before. Another class.
Oh,
I can't remember the exact question, but it's when we're dividing factors, right? The problem will be, let's say it's in parentheses x minus 1 or something, or x minus 3. And then to factor it, it's a negative on the outside of the parentheses. Do you understand what I mean? Okay, how do I know when to do that? Because that's where I keep messing up. I keep missing that right there.
The strategy of factoring is number 1, descending order. Number 2, greatest common factor, and negative leading coefficient. So that's the strategy of factoring. These are the first steps. So you have to make sure that the polynomial is in descending order, and then you have to factor out the greatest common factor and the negative leading coefficient. If you don't do that, then you're going to make it way more difficult.
Yeah, okay, I understand. The negative leading coefficient has to go outside.
Yes. Yes.
Okay. Because it's messing. What we're working on now is messing me up.